Hello, hello, hello. Is this working? Hello, hello. Yes, it is. So, um, I actually managed to get this to work. Um, I'd like to go through it though because there are some checks that I think I should validate, and I should do it in front of you know, public audience, even though no one watches, because it's very interesting why it was so difficult for me. Um, I suppose it's because I was trying to formalize it mathematically. Um, even with like working with sets. But I think this is a good lesson for me. Sometimes you have to, think of the engineering part of the problem. So you've got the mathematical formulas fine, but there's some kind of engineering in the offsets for arrays, etc. Um, anyway, it's kind of interesting. So what I ended up doing was, I don't know if you remember, but um, not that anyone's watching. I'll talk to the imaginary audience. I try to, run this little table, right? This this table helped a little bit because it really just sets out the matter of fact, right? You've got index of letters 0 through to 25, and then you've got the index of shells, the electron shells, where we've got this kind of offset. And of course, even though there's 26 letters in the alphabet, we're two behind. And that's because we have shifted by one, and we've got the offset of 1, 2, of 1, 2, of 1 also. So that kind of vindicates sorry, it explains that, right? And I think when I realized that the problem was, I think I had realized it, but it takes a little while to process these things, that it really is just an indexing issue. I I stopped. I did do mathematical formulas after that, but it just wasn't getting anywhere. So I thought, let me just go back to my code and just try it again. And I don't know what was different this time, but I started to write down different things. Like I think I started off with I was like 26 minus da 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 da, and I just kept doing these things to try and say like if I put 5 in, this would be this. If I put 6 in, this. I just kept doing basically what I was doing with the formulas before. Um, but then I thought, then I thought, stop. Like, what are the actual facts here? Like, this isn't. I mean, this wasn't as easy as I'm making it sound now. But the fact is, there are 26 letters, and I need a range of 21 if I'm going to put in a 5. No, I need to have a range of 0 or 1 if I'm going to put in a 5. So I'm like, well, how do I get that number? Well, it's 26 minus 21. And that's all I asked myself, like, how do I get the range? And then I was like, but 21 seems uh, like I remember 21, and 21 of course is alphabet numbers minus the F letter index, 5. And I was like, hang on, 5 is what I put in, and 5 is the difference, and I've got two variables here that I understand. So that was a big turning point. So then I thought, I wonder if I put 6 and 7 in, and I was like, oh, if I put 6 in, that will go to 20, 19, etc. Right? And then I realized, after a bit of back and forth, because I kept putting the wrong numbers in, that I was onto something. I was onto a pattern now. So this kind of reversal pattern. So the last part of the puzzle was how do I invert this so that I'm not left with um because I put in 5. I do, maybe I didn't have to invert it anymore. I can't quite remember this part, but um it's alphabet minus n gives me the range, but I don't want 5 to be, no, that's right, sorry. It's, yeah, it gives me, yeah, that's right. So I don't want 5 to be 21. I want it to be 5. Well, 21 minus 21 is 0. That's an offset of 0. And then 21 minus 20 is an offset of 1. And 21 minus 19 is offset of 2. And I started to realize that there was an offset coming. So actually, if I do this minus, so it's basically ergo 21 minus, what was it again? Yeah, it's basically it's 26 minus n gives us 21. 21 I already know as the alphabet's numbers minus the F letter. So it's 21 minus that number. So let me just show you in the code, because maybe not explain that well. I think I'll be able to do it better if I just go along here. But you can see here that I've set A equal to whatever. So it's the 5, because it's the index of letter F, plus this max range. And the max range is the length of the alphabet minus the F. So that's the 21, right? This was the interesting part I wasn't getting before. Now it's 21 max range minus a mapped value. And this mapped value is the length of the alphabet minus the number that you put in. The length of the alphabet minus the number you put in. And that gives me that mapped value. So then I started to figure stuff out, because then I started to put in like a little function machine, right? So I was like, if I put 5 in, what do I need to, get out? I need to get out 5 and all this stuff. And I was like, so this needs to go 21 minus 21, and that would be the function. Then it would be 21 minus 20, and that would be the function, and so on. And just these little drawings started to help, and I almost wish I had recorded it, but anyway, I'm telling you, so it's fine. So this is the magical part here. I've inverted with the mapping value to get it back to 0. So now I've got an offset of 0 for 5, and of course for 26, and so on and so forth. So 6, 7, 8, 9, we've got these little offsets going up to 26, right? But then we've got this problem. This is the other engineering problem. Maybe this is the engineering problem, not the other. So first of all, if I've got 0 remainder, I need to do at least one iteration, right, to actually add something to it, because 5 must give me a G. So I've said if that is equal to 5, ergo the 0th index, then plus 1 to it, basically. And then I've said if this is greater than the alphabet minus 1, then set it to the alphabet minus 1. And I think this is where I'm not so sure, but I'll explain why I did this. And finally, if A is greater than 5, then allow it. Obviously, this would catch the other one, so it wouldn't get to here. And of course, now we've got from 5 to that kind of engineered amount. Allows me to get access to my current iteration, and I can plus 1 to it. So let's just try and vindicate some of these. This one, if I start at 5, because my equation here has given me 5 back, and 5 minus 5 is 0, then I'd need to offset it at some point to get that first iteration. So let me just save this, and let me just also do it and see where we get to. So working alphabet thing. So instead of plussing 1, and we just let it be starting from the 1 I need, right? Then it would be plus 1 here, yeah? But then if that was starting from 6 and going to 25, or 26. Let's see what happens. So if I put this to be an if here, and we'll knock these out one by one. So now we start from 6 and I'll go into the iteration max bounds. So if I go here, I put in a 5. Let me just sorry, should be it should be A. Right, so this is now going to be, it's going to be 5, and so we're going to plus 1 on the array, and we'll get our one iteration. Oh, we don't. Hang on, I'm doing something silly here. So, yeah, so electrons, 5, push button. So index of letter 5. Oh, that's right, yeah. It's actually got to be that, sorry. Yeah. So now we force it to do that extra one on the iteration itself, right? So let's get that through. So there it is. The thing is, now if I go to 26, I've got an extra index accounted for. And I think the reason I've got that extra index accounted for is because if I go back to my thing here, I'm at 24 for my max index. So I've got to offset this mapping by 2. So now I've got my, if my A is greater than the length of the alphabet minus 1, because we're 25 base 0, then I set this to the length of the alphabet minus 1. But our iterations are now too many, because we're plussing 1 as well. And I mean, that in itself is a problem, right? It needs to be case by case basis. Because, I mean, if A is greater than the alphabet, then this should be the alphabet. Let's try and get that offset back in. See if that works. I don't know if that'll work. That's working, 26. So we're still 1 out. Let me just double check what I've just done. So iteration max, so if A is greater than, let's do this. If A is greater than, and this was minus 1, so we'll just take it from here. Sorry. Okay. So that's going to work, and this is going to work now. No, it doesn't. And that is because are we getting into there? Yeah? So we're getting into here, and our iteration max bound is 26, but it should be 25, and we're getting the length of 25 here. So we have to minus 1 here. You see? So I can't say I knew that before, but it's just interesting that this has become an engineering issue because of that 2 offset. The offset from the fact that we've shuffled to base 0 on the alphabet, and the fact that we are 1 off, or 2 off on the indexing for the table alignment, the mapping, you see, because these have to map somehow. And that's why that was so difficult, because I think from a purist point of view, I was thinking this is possible with less, and I just don't think it is. I mean, let's push on. If I were to then say, okay, so this is required because I need to do my first iteration, um, and let me just put this back. Yeah, let me just check this works now. 5 and oh, what have I got wrong here? That's right, 0. Yep, and 26. Oh, breakpoints A. Z. So yeah, so let's try something else then. So let's say otherwise we're good. Well, this is a range between everything we wanted anyway. So setting it equal to this f plus, the offset thing, the mapping thing, that seems fine anyway. So what else can I improve upon? So I've got this last part that I can improve upon. Well, if my current index is trying to, so if there's 26 elements in my thing and my current index is always going to be one off, I'd have to start with from one more, right? But then I've still got this problem of I've got to increase the bounds. So what's the difference, right? If I do a +1, I have to increase this bound as well. But then I just take it away from there. But I mean, what's the point? I don't even know if that's going to work now. Let me just see. It will be shuffled one forward, so it should work. Yeah. So now I've just got 2 pluses rather than just the 1. So if we then go and look at the index of letter F, then how would I get that -1 or +1 naturally? Well, what's the max range again? The max range is the length of the alphabet minus the index of letter F. So that makes sense, right? There's 26, and we could do -1, but I need to +1, and I could do +1 here. So I just feel like this is probably as good as it's going to get. I think it makes sense, although it's not simple by any stretch of the imagination. I can't see how to make it any better. So struggle 1 was this mapping, and struggle 2 was the 2 offset, like understanding why it was there. I guess I'm still a little inclined to say this isn't very beautiful. Let's see. If you've got the letter 26 minus 5, it's going to give me 21. And this is that offset. Now, if this was going to be 20, then you'll get your 1 back. And if so, it would be 26 minus 20. No, it wouldn't be. It would be 26. 26 minus 5 equals 21. That would be 21 minus 20 equals 1. 21 minus 20. And then it would be. Sorry, it will be max range. it'll be 20 minus 21, which would take us 20 minus 20, 20 minus 19, so it'll make us negative. So I can't do that. But I could pull this one down. If I did that, then this would be 20. Then it would be 20, 1 take away 20. 21 it'd be 20 minus 20. So this would all be offset. Okay, so if I did that, maybe that does make some sense. At least at that point. So this would become, let's see if I can do this. How do I just put my marker there? Maybe I can't. Interesting. Let me just pull up a notepad here. So this would then become so 25, right? And this would be minus 20, 19, 18, 17. I'll just do it, because why not? Maybe this does make more sense. So now so because this kind of makes sense, because we are on a base 0, so maybe we should say that up front. We're going to minus 1. The index letter hasn't changed, the max range has changed, but the map value has also changed, because this will be this as well. That might mean that we can remove one of these now. Let's see, so if my A is equal to the index of letter F, so if my 5 plus, so it's not going to be ever, so this might now be able to be commented out. Let's put this back here. Now the index is going to be 6. I don't know what that's going to be. I can't bother to work it out in my head, so let's just run it. So now it's going to be 5, 2, iteration max bound. Oh, is equal to A. Sorry, I think I did that last time. 5. So it's going to be from 5 to 5. And this would be, let's see, 26 would be from 5 to 25. Now that sounds pretty good. Actually, oh, it doesn't. But now we start at that, we can plus our 1 again, but also if A is greater than the length of the alphabet, it just cannot be now. I mean, unless you put one more than 26, right? Because A, index of letter F, plus 20 minus That -1 is not good. Where's that come from? -25 minus 26. Ah, now that is interesting because we are not. So it is off by 1, but we are not because we want to put 26 in to get our z value. So we'd have to plus 1 to that. But what happens if we put 5 in there? Because then it's going to be 26 minus 6. 25 minus 6, sorry. Now that is interesting. So some water. So we've now got an adjusted length with an index of 5, and the index of 5 does make sense in our array, and the 25 does make sense in our array, and the map value is from our input, so n comes in as 5, and that would now be 25 minus 20, and that would equal 5. And then if I do, that would equal 5, yeah. Now if I do 26, I put in 26, see, I've already had to adjust it here. So if I go back to my other thing, what did I have? 26 minus 1 is 25. Oh, yeah, actually this might be doable. So what happens if I put 26 in? And it will be -1. And that's where we got that from. So these all need to be adjusted again. So it's actually seems like I don't need that. And why is that? Let me just try this first. 26. And 5. So it's +1. And that's happening because it's not running the once. I can feel a little bit snookered in, you see. But at least now, I mean, I can go back to this and I just change those other values, right? So I put that back in. And this would be 20. Oh, actually, that was a bad idea. Let's just do 26 and 26. Oops. Oh no, it's not. It is 25, but it's going to be no. It's both changes. Okay. No, it's that is adjusted, and this is adjusted. So 26 minus 20 is now 6. That's right. So if I put 5 in, we've got the amount of the alphabet, but this is not what we've done. So we've got 26 minus 20, which is going to give me 6. Oh, I've changed my bloody keyboard again. Equals 6. So this will equal 7. Let's just do this all the way. Alright, so now we've got some real problems. So if we were to do it this way, we end up with, because don't forget, this is what we are putting in. So this really does need, I mean, even then, we've still got an extra one. I think the other one makes more sense then, doesn't it? The other one makes more sense. So if we go back to our changes here, if we set it as 26 and all that stuff, then we have to do the if statements here to settle the score. The equals 0. So the first check is, if it's the first one, then we want to do a run. And because we've done that, then we have to say -1 run. And because we're on an offset in the index, we need to +1 on this. I think that makes sense. I'm happy with that. I'm happy with that. Very interesting. Very, very interesting stuff. So we have a working part for that. Took a very long time to get to. I apologise. But that is working how I wanted it to. And I think, maybe some tomorrow, because I've just covered this with my little bit of code. I mean, that was just not even important stuff really. But I guess it a bit of a training session for me. So yeah, interesting, and speak to you guys later. Bye for now.